Sixth graders, make sure you have your Unit 8 probability notes next to you and a calculator. Reminder, when it comes to the notes, you can be doing them digitally. That would not be what I would recommend though. I would either print them out if you can or write them down on a sheet of paper. Yes, that might take a little bit more work to write them down on a sheet of paper, but the digital version just is not as easy to look at, especially with computer formatting. With that said, we're going to work on some probability again today. Our goal is I can determine the probability of an event using the ratio between size of the event and the sample space. We've worked with sample space already. We've worked with identifying specific events. We are totally ready to do this. Again, make sure you have a calculator next to you and your notes as well. Now, who would like a piece of candy? If we were together in the room, I would pick two people to come up to the front of the space and they would actually get a piece of candy, but we'd have to decide between the two who would get it. So my question for you is, what would be a fair way to decide who gets the candy? Imagine two kids standing in front of the classroom right now. Who should we decide gets the candy? It has to be a fair way. You might think, well, Miss Clover, we could do rock, paper, scissors. What's another way? We could flip a coin. Yeah. Which method should we use? Rock, paper, scissors, or flip a coin? Why? Think for a moment. Which method would be a good way to decide who should get the candy? It has to be a fair way. And why? Well, I would decide by flipping a coin. So we could say person A, heads or tails. They pick heads. Person B has to pick tails. So then Miss Kluger would flip the coin. And whatever the coin landed, whomever picked that would get the piece of candy. That would be a fair way to decide who gets the candy, right? Because everybody has a fair chance of getting the treat. Well, that's what probability is. And all probabilities out there in the world fall on a number line between and including the numbers 0 to 1. Let's take a look at that number line. All chances of something happening fall right here between 0 and 1 and actually including. So it's called inclusive, meaning you can have a probability of something being 0. You can have a probability that's considered unlikely. You can have a probability that's an even chance, and that would be our coin flipping, right? You can have a probability that comes up being likely to happen. And you can have a probability that's certain to happen. It has a 100% chance of happening. It is going to happen. Let's take a look at this a little bit closer. So there's that probability number line. Remember, it's between 0 and 1 and actually including 0 and 1 as well. What are the chances of you never having to learn math in your life? Where would that fall on the probability number line? It's impossible. The chance of you never having to learn math in your life, the probability of that is impossible. Because the opposite of that, you have got to know how to work with numbers. So the probability of you never having to learn math is impossible. What about choosing a red marble from a bag of 1 red marbles and 3 green marbles? Well, how many marbles are there altogether? 4. How many of them are red? 1. So you have a 1 in 4 chance. That's about 25% chance of happening. That would fall between 0 and a half. So the chances of you picking a red marble from a bag with 4 marbles is unlikely. What about rolling an even number on a 6-sided die? Well, how many even numbers are on a die? 2, 4, and 6. That's 3 out of how many total numbers are on a die? 6. So that's an even chance of happening. How about you smiling sometime this week? Where would that fall on this probability number line? That's certain to happen. Maybe me just saying the word smile made you smile. Or you're like, no, not at all, Miss Clover. But it is certain that you will smile sometime this week. That is a certain event. So again, all probabilities fall on this number line, including 0 and 1. Let's turn to our notes now. In that first chunk, we're only going to define one vocabulary word today, and that is theoretical probability. Say that with me. Theoretical probability. That is the chance of something, that something is an event, happening. What the math, fill that in, says should happen. Go down to chunk 2 in your notes. You have a ratio. Remember, a ratio is a comparison of two or more numbers by division. This takes us back to Unit 4, is when we worked on ratios and proportions. Our theoretical probability ratio, this is really, really helpful. We are comparing the size of the event divided by the total sample space. Actually, that's a repetitive word. Sample space. So when you think about the size of the event, it's what you want. Write the word want above that in your ratio. When you think about sample space, it's the total number of outcomes. So write the word total next to the ratio in chunk 2, just like I'm showing you here. So our ratio for theoretical probability is what we want over the total. Let's take a look at some example problems. So we have a 6-sided die is rolled once. It is a fair 6-sided die. So imagine you have a die in your hand and you're going to roll it once. Probability is written in a really unique way. This right here means what's the probability of this event up here that you roll a 6. So probability 6. Well, it's what I want over the total. That is how I figure out theoretical probability. So what do I want? I want a 6. How many 6s are on this fair die? You just have one of them. 1. So that's what I want, the number that represents the 6 on here. There are 1 of them. Over what's the total sample space on this die? Well, when you roll this die, you could roll a 1, a 2, a 3, a 4, a 5, or a 6. How many is that? 6. So here is the theoretical probability of rolling a 6. Make sure you have this in your notes. Now, probability is really cool because you can write it. It's the chance of something happening. That's cool in itself. You can figure that out. And right now, with all that's going on in the world, 6th graders, a lot of very, very intelligent minds out there are using data. They're looking at the chances of things happening. And so probability is used on a daily basis, but it's also very, very helpful. It helps those minds out there predict what's going to happen. So with that said, we can write probability in 3 ways. We can write it as a ratio. In this case, it's a fraction because my total, right? I can call this a fraction as well. My total is my denominator. We can also write probabilities as decimals. And finally, we can write probabilities as percentages. And personally speaking, I like to see probabilities as ratios and percentages. On your assignment, I may ask you to write it in all 3 forms, so ratio, fraction, decimal, percent, or I may ask you to write it in 1 form or 2 forms. Pay attention to that. So how do we change a fraction to a decimal again? Remember, a ratio, in this case a fraction, is a division problem. So we take our numerator and we divide it by our denominator. So right now on your calculator, put in 1 divided by 6. What do you get? When I do it, I get 0.16666, and then at the very end of your calculator, it might round that last digit up to a 7. Remember, your calculator screen can't extend for forever, so it rounds up that last digit if it can. Now, since my digit 6 is repeating, what can I bring in to show that that 6 is going to repeat? A notation bar. Now, another way to write probability is as a percent. Do you remember how we go? Imagine our triangle back from Unit 5. How do we go from a decimal to a percent? We listened and watched part of the movie Madagascar to help us. We move move that decimal 2 times to the right. That means we're multiplying this decimal by 100 because a percent is in relationship to 100. So if we move it once, that's multiplying by 10. If we move it twice, that's multiplying by 100. I get 16.66666. That 6 is going to repeat percent. So I can bring that notation bar back in, and then I don't need all those other 6s, but I got to make sure I bring my percent sign in because this means for every 100. So fraction, decimal, percent. This fraction again can be called a ratio as well. Next, let's look at the next probability problem. We have probability, notice how I read it, not a factor of 2. So what are the chances that when you roll a die, you do not roll the factor of 2 or a factor of 2? Well, first of all, let's look at what are factors of 2. Remember, factors are what we multiply to get the number we're looking for. In this case, we're looking to get the number 2. What numbers can you multiply in a die to give you 2? 1 and 2. 1 times 2 is 2. So 1 and 2 are factors of 2. That means all the other numbers on a die are not factors of 2. 3, 4, 5, 6. Miss Kluver, you might go, what about 4 and 6? Well, those are multiples of 2. Remember, multiples are what we get after we multiply. So with that said, I'm looking for not a factor of 2. How many not factors of 2 do I have here? 1, 2, 3, 4. What I want, not factors of 2, 4 represents that. Over what's the total number of outcomes when you roll a die? What's the sample space? 6. I could roll a 1, a 2, a 3, a 4, or 5, or a 6. How do we change this ratio to a decimal? Numerator divided by denominator. So go ahead on your calculator, go 4 divided by 6. See what you get. Can you bring a notation bar in? Yes, you can, because that 6 is going to repeat forever. Your calculator might round that last digit to a 7, and that's okay. So we want to bring that notation bar in to show that the digit 6 repeats, and you could erase all these extra ones. How do we change a decimal to a percent? This probability right here, how do we change it to a percent? We multiply by 100. So move it, move it. Move it once, multiplying by 10. Move it twice, multiplying by 100. You're going to get 66.6 repeating percent, right? Because these 6s are going to repeat for forever. All right, we have 2 more problems to do together today, and then we are done. And I know your note sheet will not be complete. We'll come back to it in a different lesson. So now we're switching the events. We're not rolling a die anymore, we're spinning a spinner. This spinner right here is cut into how many equal pieces? 1, 2, 3, 4, 5. These are equal pieces, so the chances of spinning a yellow is the same as the chances of spinning a blue. That's important. And games are all focused on the fair chance of people winning. Games wouldn't be fun if the chance of winning wasn't fair for everybody playing the game. So it's important to know that this is a fair spinner. We have our ratio that we're going to refer to again. So a spinner is spun just one time. What is the probability? Remember how I read this. Probability you get blue or white. How many blues are there over here in my event? 1. How many whites are there? 1. So there are 2 outcomes that I am in favor of, that I want. So 2 is going to be my numerator in my ratio. How many total outcomes are there on this spinner? Well, I could spin a yellow, a blue, a green, a white, or a red. That's 5. So 2 to 5, or 2/5, how do I change this to a decimal? We're going to show the probability in all 3 ways, 6th graders. Numerator divided by denominator. So 2 divided by 5, type that in your calculator. You should get 4/10 or 40/100. 4/10, 40/100, I could annex a 0 back here. I could keep annexing zeros forever, and it would be the same value. Now we have our probability, the chance of a blue or white, shown as a decimal. Let's change it to a percentage, because I think, again, the ratio and percentage is the easiest way for my mind to comprehend the chance of an event happening. So how do I go from a decimal to a percent? Whoopsies, it came in pretty quickly. Move it, move it. Move that decimal 2 places to the right. What's going to go on that empty hump? 0. So 2/5, 4/10 is the same as 40%. So you have a 40% chance of that happening. If you go back to the probability number line, if I do that quickly here, a 40% chance of happening, that's not quite 50% or an even chance. So it's still an unlikely event to happen. Looking at my probability scale, I can use the word unlikely to describe that event of spinning a blue or a white on the spinner. Next, let's look at the probability of not spinning a yellow. So that means you want everything else except yellow. Well, how many outcomes are focused on what you want? You don't want yellow. So if you cover up yellow on the yellow slice with your thumb, how many are looking at you? 1, 2, 3, 4. So what you want is represented by the number 4 out of how many total outcomes are there for this event? 5. So 4/5, or 4 to 5, is the probability of not spinning a yellow. Let's change that to a decimal. So 4 divided by 5, 8/10 or 80/100 or 800,000, right? Because I could annex zeros back here for forever. Let's take that to a percent. So we move it, multiply by 100. What's going to go in that empty hump? A 0. So 80%. Now where would that fall on our probability? Where would that fall on our probability scale? 80% chance of something happening. Well, it's greater than 50%, so it would be a likely event to happen. Look at it, even says 4 in 5 chance right here for this one. So what we just focused on right now was theoretical probability, the chance of something happening, what the math says should happen. So with that said, now you're going to go and you're going to work on your assignment for theoretical probability.